And as we mentioned earlier that the restoring force is a conservative force, so it means that we have the relation that the total energy is a constant. Okay, this relation, the total energy is a constant, and this is an advantage of the conservative system. That is, in some calculation, we can do the calculation if we don't want to know the detail of the motion as a function of time. Okay, if we don't care about the time, we can use the conservation of energy to calculate something. For example, we can calculate the velocity without involving with the time or solving the Newton's second law. This can be done like this. You know that the total energy is a constant. E is equal to is a constant. Okay, and we know that it is equal to the 1/2 of Ka square, and we also know that it is equal to the 1/2 of mv square plus 1/2 of kx square. So we have that 1/2 of k square is equal to 1/2 of mv square plus 1/2 of kx square. Okay, if we want to solve for the velocity, we will have that v square is equal to v square is equal to v square is equal to k over m of a square minus x square, or v is equal to the square root of k over m square root of a square minus x square. But from the definition, we know that square root of k over m is an omega. So we have that v is equal to the omega of square root of a square minus x square. You can see that if x is equal to a, if x is equal to a, we have that v is equal to 0, which means that at the maximum displacement, the velocity must be 0, it should be. Okay, and when x is equal to 0, v is equal to the omega a, which is a maximum value of v, right? Because if we look at the term in the square root, you can see that the maximum value can be achieved when x is 0. Okay, if x is negative, the square of x is positive. So the minimum value of x square is 0, and the maximum value of the term in the square root is a square. Okay, so we have that v when x is 0 is omega a, which is the maximum value of v, and also the v at x equal to a is the minimum value of v also. Okay, so we can have this relation. You can see that we can have this relation without solving the Newton's second law, but we can start from the conservation of energy, this and this, and we can get this conclusion.